Taking a deeper look into the double bond itself, we can use the example of ethylene or ethene. This is a 2-carbon long double bond. This is the simplest double bond you can have between 2 carbons. Remember that when you have a double bond, the carbons involved in that double bond are sp2 hybridized. So remember, double bonds means you are sp2 hybridized. We've seen this when talking about hybridization in the past. And those carbons have this trigonal planar geometry. So they are flat because of the pi bonding that is occurring in this double bond. Double bonds are also not quite twice as strong as a single bond, but stronger. And they are shorter considerably than the single bond. Here's just another example to look at kind of the properties of the double bond when we look at a slightly longer chain. Here's propene. This is 3 carbon long. There is a double bond and a single bond in propene. Remember that double bond carbons are sp2 hybridized. So this carbon and this carbon are both sp2 hybridized. However, the carbon that is in the single bond is sp3 hybridized, and it is a tetrahedral. Again, when we look at bond length differences, we see that double bonds have a much shorter bond length between the carbons as opposed to carbons involved in a single bond. So this carbon here to this carbon here, the single bond, is much longer than our double bond. Now let's elongate this out to the next possible length chain of a double bond, which is our butene 4 carbons. Now, butene is interesting because it allows for the ability of having isomers. And we're going to talk about isomerization in double bonds. So this is the simplest example of isomers in double bonds. If you look below, you can see that butene actually has multiple versions. It has some constitutional isomers, and a reminder that constitutional means that you have changed the placement of the bond. Bond order has changed. And it also has stereoisomer potentials. We'll talk about those in a second. Let's first talk about the constitutional isomers. This one might be easier to see in that you have a 4 carbon long chain. So here's 1, 2, 3, 4. Where could the double bond be in a butene? Well, it could be here. This is starting at position 1 and going to 2. Or it could be in the middle here. This is starting at position 2 and going to 3. Or we could have something that is like this, which still technically has 4 carbons. Here's a carbon, here's a carbon, here's a carbon, and here's a carbon. So still technically 4 carbons, but its arrangement is different than these up here. Okay, so here's 3 different constitutional isomers that you could draw. These are all ways to draw 4 carbons with 1 double bond that have different bond placements. Now let's talk about the stereoisomer. Technically, this version of our double bond has 2 versions. it has stereoisomers. That is, it also has another version that has the same bond placement, same bond order, except different positioning in space. This is its same bond order, but different positioning in space version. We've actually talked about this type of positioning in space in rings. It's called Cis and Trans Isomerization. It is a type of stereoisomer, and technically they are diastereomers. They are not mirror images, but they are still stereoisomers. This type of positioning occurs because of the restriction of the double bond.